Good evening, students. Am I audible?
Yes, sir.
Okay. So we get started. So before we get started, is there any doubt from yesterday's test you guys have? Is there any question that was tough or something? Was it easy or tough, guys?
Sir, it was fine, sir.
Okay. Is there any question that you didn't understand or you couldn't solve?
I solved, sir, but then I don't know if it is like correct.
I don't know if it is right or wrong.
Yeah.
Okay.
Sir, today until like which time we can submit the answer papers?
You can do it before 6:30 or 7 max.
Okay, sir.
Okay, then we'll continue with loss of motion itself. So we'll see the next topic, that is the conservation of momentum, which is also called as conservation of linear momentum. Okay. So tell me one thing, guys. So how is linear momentum related to force? What comes to your mind when I ask you the relation between when I ask you the relation between linear momentum and force? So the topic is conservation of linear momentum. Okay. Now tell me, what comes to your mind when we speak about conservation of linear? First of all, what does Newton's second law state? F external is equal to the rate of change of linear momentum, delta P divided by delta T. Right? So if F external is 0, so what do you mean by F external is 0? That is the sum of all the forces acting on a system. If I put it to be equal to 0, can I say delta P by delta T is 0, which implies delta P is equal to 0. So when delta P is equal to 0, what can you say about the momentum? P final minus P initial will be equal to 0, or the final momentum will be equal to the initial momentum. Accepted? So what comes to your mind when we see the word conservation? So what do you mean by conservation of something? Conservation means something is preserved, right? It is not lost. Right? So here, looking at all these mathematical expressions, you understood that the final linear momentum is equal to initial linear momentum. If that is the case, when will this kind of a scenario occur is what we need to answer. Can you guys tell me? Can you guys tell me when will this happen? Try no. See, always the best way to learn physics is to try framing sentences on your own. If you start mugging it up, especially 11th standard, you can forget about physics. It's going to be a nightmare only. Whether it is right or wrong, I want you all to try it. I have written some mathematical statement from what I know. Okay. Now try to define it. Try to give an explanation or a statement for it. So you only want notes. That's it. I'll give you notes. You'll blindly accept it. That's it, right? Okay. Write it down. Write down the heading as conservation of linear momentum. Write down the statement for it. When the net external force acting on a system is zero, when the net external force acting on a system is zero, then the linear momentum is said to be conserved. Then the linear momentum of the system is said to be conserved. Okay. So after you write down the statement, copy all these mathematical expressions. Okay. So once you're done, listen. Let's take an example to understand what exactly is this mathematical statement. So let's say I have an object of mass MA moving with a speed UA, and there is another mass MB which is moving with a speed UB. Okay. So what are the conditions if these two objects should come in contact with each other? What should be the relation between UA and UB for these two objects to come in contact with each other?
Sir, UA should be great.
UA should be greater than UB. Perfect. That's right. Okay. When this is happening, can I call this as before collision? So that is the thing. And let's say these two objects are colliding each other at one point. Let me call 1 minute, wait. Then I stop writing. 1 minute. Listen. So when they both are colliding, if I call this as A and this as B, so this will be the force exerted by A on B, and this will be the direction of force exerted by B on A. If I consider both of them as rigid bodies, I've already told you what is the meaning of rigid bodies. If I say rigid bodies, what is the relation between FAB and FBA in terms of magnitude? FBA will be equal to FAB. So from this, can I conclude that the net external force acting is zero? According to Newton's third law. Can I say this? Right. So after collision, what will happen? I'm assuming that both the objects are still moving in the same direction. Are still moving in the same direction. MB, if they call BT. If these objects should never meet again, what are the conditions? If
VT
these
should be greater than or equal to V.
greater than or equal to, okay, that is also right. VB should be greater than or equal to, because it is equal to VA, then the velocity separation will, the velocity, relative velocity will be 0. So they will have a constant separation between them. That's right. Right. So what is the initial momentum of the system? So this is before collision. This thing is during collision, and this is after collision. Correct?
Sir,
Tell me.
sir, how is force exerted by B on A equal to force exerted by A on B?
Rigid bodies.
Sir, but it should have negative sign, right?
That's why I put the arrow marks. No?
Okay, sir.
See, in physics, remember this thing. If it is a vector, if you're dealing with vector quantities, there are two ways to represent them. One is completely using mathematics. So the question you asked me is something related to mathematics. What does a user understand? See, the main purpose of writing something on a paper is when someone is reading your paper, they have to understand what is there in your mind, correct? So if you write a minus sign in the paper and let's say you're giving it to someone who knows physics, what will that person understand? What will that person ask you about that minus sign? So they will ask, are you trying to say that both the forces are in opposite direction? Because that is the meaning of negative sign, correct? For the
Yes, sir.
same person who knows physics, if you put this as FAB and FBA, and you put these arrow marks, what will they understand? That FAB and FBA both are in opposite direction because you're actually spoon feeding them by putting an arrow mark, correct? So this is a diagrammatic representation. So generally, going forward, have this in your mind. Whenever I'm dealing with vector quantities, right? If I put an arrow mark, I will assume that you guys have understood that the directions are taken care by the arrow mark, and I will not put the signs into consideration. I will put the sign into consideration only when I write them in the vector form. Now, is it clear? Are you able to understand? This is a very, very minor point, but it is important. Good that you asked. Am I clear, guys? Am I clear? Okay.
Yes,
Yes,
sir.
sir.
Right? That's good. So this is after collision. Now, what will happen? What happened before collision? What is the total momentum before collision? That is mass of object A into velocity of object A plus mass of object B into velocity of object C. One small correction is there that I need to do in this expression. Can you guys correct it? Here I've written something mathematically. That's it. I've written it mathematically. So mathematically means what thing should I have in my mind? First, look at this quantity, momentum. Okay.
You have to draw the arrows.
Yes. Because when you're dealing with vector quantities and you represent them mathematically, ensure you draw the arrow marks on top of it. Now will you be able to understand? Now, if I put an arrow mark like this, now you will understand that you need to go to the diagram, and if they both are in same direction, then you will write UA plus UB. If they both are in opposite direction, what is the change you will make? This UB will be written as negative value. You're able to understand whichever is in the opposite direction, for that you'll put a negative value. So this is the total momentum before collision. So please tell me.
Sir, could we draw the arrow mark pointing the opposite direction? Sir?
Like this, sir?
Yes, sir.
No, you can't do that.
Okay.
Because whenever you're dealing with vector, no, the basic representation of a vector is this thing. The symbol with an arrow mark with the head, sorry, with the starting point on the left hand side and the ending point. That is the arrow mark on the right hand side. That is only rule. You should not draw it like wrong. Okay.
Okay.
So this is total momentum before collision. Now we are able to understand one thing, that throughout the motion of the objects. Okay, so here, if you recollect the statement which I gave you, what is that I gave you in the statement? When net external force acting on, I use an important word. What is it? Acting on. What is the word I used? Please check your notes and tell me. The net external force acting on a dash is 0. Did you guys write it down? Okay, none of you have written. It's only one word. If the net external force acting on a system, I use the word system. No, I expected a question. What do you mean by system here? System is something which is under your observation. Here, how many objects are there in the system? You have 2 objects, right? Those are called as 2-point objects. Okay. So total momentum is MA into UA vector plus MB into UB vector. This is before collision. And what about after collision? It is MA into VA vector plus MB into VB vector. Okay. If you observe throughout the motion, one thing is clear, that the objects are moving with the next net external force to be equal to 0. If that is the case, then the linear momentum is said to be conserved. I wrote P initial is equal to P final or the vice versa, right? Then the meaning of this is MA into UA vector plus MB into UB vector is equal to MA into VA vector plus MB into VB vector. So this is what is the exact mathematical statement of conservation of linear momentum. Suppose you have 3-particle system, then you need to take the momentum of the third vector also in the vector form and write it. Okay, please make a note of this point. You would have learned the same derivation in your 9th standard, but there we would have not used any vector symbol on top of it. Okay. So with the assumption that you guys are done writing it, I'm moving on to the textbook. Let's see if there is any problem based on it. We're almost at the end. Okay. I'll teach you something important today. This one. Next topic is, see, this part you cannot find it in the textbook. The part which I'm going to teach you now, we cannot find it in the textbook in detail. You'll be able to find it, but to a very small extent, which might not help you. So the concept I'm going to explain is called as free body diagram. Free body diagram. So why this free body diagram is actually used is, it is mainly used to solve the problems in mechanics. Okay, it is mainly used to solve the problems in mechanics. So how it is used, let's see it now. First, let's understand what a free body diagram is. So before I explain what a free body diagram is, I need to explain the types of reaction forces. Okay. So what do you mean by reaction forces here? Listen. Let us say there is a fixed surface on which there is a wooden block placed. Let's say the mass of the wooden block is m. Then this mass will experience a force in the downward direction, which I can call it as mg. Correct? So this mg is the force with which this block is being pulled in the downward direction. So can I say there is a force of mg, which is an action. So tell me, how many particle system is this? You have a block and a floor. So when you have a 2-particle system, can I say that this block is exerting a force on the floor. Right. So if I call the action as the weight of the object on whom? On the floor, then the immediate question that we need to ask is, what is the reaction? Because let's say you keep a book on your table, are you able to find that the book, are you saying that the book is moving? Obviously no, right? The book
No.
is going to be at rest till you disturb it. Then what is the reaction force that is acting?
Normal.
Yes.
Nothing.
So the reaction force that is acting, reaction force offered by whom? Reaction force offered by the rigid surface. Here I'm using the word rigid surface because it need not be floor always. It can be a table or whatever it is. By a rigid surface on any object in contact with it is called normal. Okay, on any object in contact with it. Wait, I would like to add one more point. In contact with it, in the direction, in contact with it, in the direction perpendicular to the action force is called normal, and normal is represented by the symbol capital N. Okay, so what do I write in the upward direction, guys? The reaction force R is nothing but normal. Am I clear with this?
Sir,
Okay.
Yes.
Please tell me.
sir, does it mean like since gravity is acting and so every action has opposite reaction, so normal is acting?
Yeah, that is a reason. That is a reason. So see, every object will offer a what do you call a reactive force. Okay, every object. If you try to apply an object, if you try to apply force on any object, the other object will definitely offer a reaction force, and the reaction force is the general name. But there are some technical names given to the different kinds of reaction forces offered by different surface. In this context, what I'm trying to say is, if you have a rigid object and there is an object in contact with that rigid object, okay. So if you exert a force on that rigid object, the rigid object will exert a reaction force on you, which is called as normal. You call it as normal because normal is a word derived from perpendicular. So it will be exactly perpendicular to the surface of contact. Okay. So in this context alone, I'm calling it as normal force.
Sir, but the nature of the forces has to be the same, right? For example, weight force is gravitational force, whereas normal is electromagnetic.
Yeah. Need not be. Need not be. Normal is an electromagnetic force. That's it. So it is not necessary that these two types are supposed to be of the same nature. No. Not
But they
necessary.
have to be in opposite direction.
They have to be in opposite direction. That's what Newton's third law told. It never see you read the statement of Newton's third law. Did it state anywhere that the sum of these two forces will be equal to zero? The vector sum of these two forces will be zero only if they're of same nature. No. Every action will have an equal and opposite reaction. Nowhere it is spoken that it is of the same nature. Okay.
Okay, sir.
Yes. So here there is a normal force. Now see, if I take a surface like this, then I keep a block on top of it. Now, if I take the same surface to be in this way, and if I keep a block on top of it, okay. In this case, mg is in this direction and the normal force is in this direction. In this case, tell me which one is right? mg, mg. First option or second option?
First option.
It is first option.
First option, sir.
Because mg will always act in the vertically downward direction. This I've told many times. right? Now the question is, how is a normal force? That is what we need to answer. So I'll give you two options. First, second.
Second, sir.
Second, sir.
Second, sir.
Why is second right? Because
It should act perpendicular to the surface.
Perpendicular to.
yes, it should act perpendicular to the surface of contact. So this is the normal force. Okay. In a similar way, let's say there are two surfaces like this. And I keep an object in this way. One minute, guys, some technical issues. Yeah. If I keep the object in this way, and let's say this object has mass m, so weight will act in the downward direction. Then what will happen here?
So we'll have
There
two
will be-
normal.
Yes. One normal is N1 and the other normal is called as N2. Remember, for a circular object, the normal will always pass through the center because these surfaces are acting like tangents. So normal will pass through the center. I hope you're able to understand this, right? It will be like this. Okay. So now you guys are clear with what is this normal force.
Sir,
Tell me.
sir, could you go to the definition of normal force?
Tell me. Yeah.
Offered by the rigid surface. Oh, okay, never mind, sir. I got it.
Okay. Okay. Second type of reaction. It's called as tension. Okay. Listen, if there is a block like this, okay, and if this block is freely suspended in the air, what would have happened? mg would have acted and this object would have had a velocity in this direction which is not equal to 0. Accepted? Right.
Yes, sir.
Now,
Yes.
if I have to keep it at equilibrium, what I can do is equilibrium means, as of now, have it in mind that the net force acting on it is 0. That is what it meant by equilibrium. Okay. If I have a ceiling to which I have connected a thread like this. Okay, generally, if you take a thread, it will be in the form of a cylinder. If you look at it on a microscopic scale, it will be in the form of a cylinder. Let's say there is a string or a thread which is taken and I try to suspend this block with the help of this string. Let's say the string is strong enough that it is able to hold this object. Then the question is, what is the force exerted? So how many, you should always look at it like this. When I talk about action and reaction, action will be exerted by one object on another and reaction will be exerted by the other object on the first object, right? So that is what you call it as an action reaction pair. So if I take this as the first object and this as the second object, so the force exerted, I repeat, force exerted by block on string is how much? It is mg. Because the block can exert a force only due to its mass. And we will call this as action. Now the question is, what is the reaction offered by the string? So what is the reaction offered by the string? Can you tell me?
Sir, the string is continuously pulling the block and this is called as tension.
That's right. So reaction offered by the string is what is called as tension, and it is represented by the symbol T. Okay. Now, what exactly do you mean by this tension? We need to understand this, right? Now, how exactly is this happening? See, if I take this point, the point where these two objects are in contact, then the point which is holding, which is common between the string and the block, is experiencing a force like this. The point is being pulled down by mg, and the same point you're able to see is balanced by some reaction force which is happening within the string, which we call it as tension. Are you able to understand this? Okay. Now, there are certain points to be kept in your mind with respect to this tension. Please write it down.
Sir, is tension same as normal force?
No. Same in the sense? Same in the sense, what is your question? Same in which sense is what you're asking?
Sir, here at the point where the block and the string are getting connected, won't there be any normal force acting?
No, because what did I say normal forces? I
It
expected
should be on the
this.
ground level.
No, normal force is exerted by rigid objects, rigid surface. Whereas when you talk about a string is not a rigid surface, it can be bent.
Okay, sir.
Okay. So generally the forces offered by a string or rope or thread is generally called as tension. Call it as tension. There are certain, as I told you, there are certain assumptions that we take into consideration while solving the problems. So first, assumptions in the problems involving strings. Okay, first what will happen is, listen, string is considered to be massless. But is this going to happen in real time scenario? If you take that string, it is made up of particles. It has matter present in it, right? It is made up of atoms and all those things. It will definitely have mass. But what is that we are saying? The mass that the particular string which we use in our experiment or the study purpose can be ignored is what they're saying. That is the meaning of massless. Okay. Second, we assume that the string is inextensible. So what do I mean by inextensible? Its elastic property is how much? Is nil. It does not have any elastic property like a rubber band. Okay. Third, if these two, if points 1 and 2 are satisfied, okay, then the tension at both ends of the strings is the same. Okay. So tension at both ends of the string is same in the sense one end of the string is connected to block and the other end is connected to the ceiling. Means if there is a tension T acting here, then there will be a tension T acting in the other side also in the opposite direction. Okay. The reason is very simple, because tension by default is always a pulling force.
Sir, can you repeat this point?
I'll come to that point. 1 minute. My charge is over in my pencil. Just a second. Okay. So if points 1 and 2 are satisfied, what I'm trying to say, tension at both the ends of the string is the same. The reason being, tension is always a pulling force. So this might be a 1 mark question. Tension is a dash force. Is it a pulling force, pushing force, or both? None of the above. So tension is always a pulling force. So what is happening? Observe why I'm calling it as pulling force is because at the bottom, the block that is connected is applying a force mg in the downward direction. So what is the string trying to do? Is it supporting? Is it pushing the block, or is it pulling the block? So you know what are the difference?
Pulling.
What is the difference between pushing and pulling, right? By looking at the diagram, how will you say something is pulling or pushing?
Sir, if the force is acting in along same direction, it is pushing.
Okay.
Sir, if the object is moving away from the source of the force, then it's pushing.
Away from the source of the force. Okay. To make it more simple, no? If you draw a force like this, okay. If you draw an arrow mark diagrammatically, if the direction of force is towards the object, the direction of force is towards the object, we call it as pushing. Provided there is a person standing here and the block is going in this direction. If the force is away from the block, we call it as pulling. Okay. So if you observe, the tension force is away from the top. That's why it is pulling at the bottom. Okay, accepted. Now what is happening at the top? So at the top, if you see, the top end of the string is in contact with whom? The ceiling. Correct? Am I right? Now what will happen is, let's assume this mg is there now. Okay. Now I want you guys to analyze it because I don't have an equipment to show it. Let's say this surface, let's say you're designing this, okay. Let's say you're designing a dummy ceiling using a thermocol sheet. Okay. And let's say you suspend, you have seen those weighing stones, right, which they use in these vegetable market and all. They'll have a physical balance on which one side they'll keep the weighing stones, and one side the vegetables will be kept. Have you ever observed it?
Yes,
sir.
sir.
Right? Let's say you're using a 5 kilogram weighing stone and tying it across a rope and hanging it to the thermocol sheet. Okay. So depending, there are certain factors with respect to thermocol sheet, right? What are they? Depends, the strength of the thermocol sheet depends on how much thick material you're taking, what quality of material you're taking. Is it A class, or is it A grade or B grade or C grade material? All those things are there. Okay, in this case, let us assume that it is a sheet which can, the sheet that you have taken can withstand only 4 kilograms of weight. Okay, it can withstand only a 4 kilogram of weight. The meaning of that is, if I take this thermocol sheet, if I place a block of mass 4 kilogram on top of it, yes, the thermocol sheet will be able to hold it. If you place it, it means, let's say your hands are here, you hold it in your hand, it's hanging in the air. I hope you guys are able to understand, like how you hold your book at the ends, and in the middle, you place a 4 kilogram block, yes, the thermocol sheet is able to withstand it. If it goes beyond that, you can see that there will be a deformation taking place. Means what is happening at this point? It is breaking. Guys, are you able to understand? Are you able to visualize what I'm trying to say?
Yes, sir.
Yes, sir.
Now think about it. Now I have certain questions. Okay. In this context, number one, you're holding the thermocol sheet in the air. Okay. Then what are all the forces acting on it? There is a force of 4 into G. I'll call it as G. I'll take it as 10. Okay. I'll take 4 into G, 40 Newton in the downward direction. And the thermocol sheet is offering a reaction force of how much value? It is
Same,
offering
sir.
exact 40 newtons so that it is able to balance it. And this reaction force in this context will be called as normal force. Correct? So what happens if the weight is increased to 4.1? What will happen if the force is increased to 4.1? The weight in the downward direction will be 41 Newton, but what is the maximum reaction force it is able to offer? In this case also, the normal force that it can offer will only be 40 Newton. Why? Because that is the strength of that material. That's it. Correct? You're able to
Yes,
understand?
sir.
So it is going to break. Why? Because it is not able to offer an equal and opposite force. It is offering an opposite force, but it is not of equal magnitude. Hence, it is going to break. That is when the object.
Sir,
Please tell me.
sir, in this case, isn't the hand offering the normal force?
I'm ignoring all those things. Yeah, hand is also offering. I'm not denying that fact. I'm ignoring all those points. I just want to explain about something strength. Okay, concentrate on this. Assume as of now
Okay,
the
sir.
normal force is 0 by hands. I'm not getting into those technical details. What you asked is right. Okay. So did you understand why it is going to break? My objective is to explain why it is breaking. Just an example. So it is 40 Newton. It is not
Yes,
able to offer the normal reaction. So it is not able to withstand this strength. It is happening because the block and the thermocol sheet are in contact with each other. Correct? Now what I'm doing is, the same thermocol sheet you have taken, you're doing a different kind of activity. Now you have suspended 4 kilogram block here. Okay. And the thermocol sheet, let's say it is kept between two fixed surfaces like this. Okay. Now, will this sheet, the same material, okay, same material, same everything. It's exactly a replica piece of it. Okay. In this context, will this thermocol sheet be able to withstand this 4 kilogram weight? What do you think?
Yes, sir.
Yes,
Yes,
it
sir.
will. Because its strength is how much? It can withstand a force of 40 Newton. That is what they told. Right? When you went to the shop and bought it from the dealer, they told that it can withstand 40 Newton, and the manufacturer also gave it on the sheet from where you bought it. Okay, this 40 Newton. But the question is, what is the difference between this scenario and this scenario? There, in the first scenario, the 40 Newton is directly applied on the thermocol by creating a physical contact. Correct? Whereas here, what did you do? You applied the same 40. How did you say it is going to work? Because this 40 Newton is what is going to get exerted at this point also. Am I right? So this 40 Newton is acting on the string, and the string is acting as a medium which is creating the contact between whom? Between the weighing stone and this thermocol sheet, unlike the previous case. Correct, Ada? You're able to understand? Now, if I increase this to 4.1 kilogram, like how I did in the previous case, what do you think is going to happen? If I increase it to 4.1 kilogram, then there will be a
It will
force
break,
of,
sir.
why will it break?
It
I am
is greater
assuming that
than
this,
it is.
I am saying that the string is strong enough. Okay. So now I have some questions running in my mind. In the first case, I know it is breaking because that 41 Newton was a direct point of contact on the thermocol. So the thermocol didn't offer a force of 41 Newton. That it could, the maximum force it could offer was 40 Newton. Hence it broke. Okay, accepted. But in this case, how is it breaking? Breaking is the right answer. Breaking is right. It will definitely break. But why is it breaking? It is because, observe now. Observe this point. This 41 Newton is there, no? That 41 Newton will try to create a force on which material? So here there are three materials. What are they? One is weighing stone, second is a string, and the third is a thermocol sheet. There are three different objects. So the 41 Newton, the 4.1 kilogram block will create a force on which of these three materials? Or which of
The thermocol
is it directly creating? Is it directly creating?
via the thread.
There is a medium in between. Correct? So there is a medium. So whichever medium or whichever object to which this block is in contact with, it can create a force only on that because it's a contact force again. Right? So this, if I try to draw a separate diagram, guys, understand there is a force of 41 Newton acting in this direction, and it is able. So initially it was 40 Newton that was acting here, and the tension here balanced it. So that this tension was how much? This tension was exactly equal to 40 Newton according to Newton's law, which was in the previous case. Correct? Now, if I take the tension here as P, now the string is in contact with whom? The string is in contact with the thermocol sheet. Correct? So now you think of the logic of why it is breaking, because the string is the one which is exerting a force. Will it break in this way or this way? You tell me, is it going to break in the first format or in the second format? Means if the thermocol sheet
First
was,
format, sir.
it will obviously break in the first format. It will be a V, right? Not an inverted. Why is it happening? Because the point where it is in contact with the string, at that point maximum force is acting. Then who's exerting that force? Obviously, the object which is in contact with the thermocol sheet. Who's in contact with it? It is the string. Correct? So the name of the force that the string is exerting on the thermocol sheet at the exactly opposite end of the block is also tension T. Remember, this value and this value will be the same only if the string is considered to be massless and inextensible. That is the meaning of my third statement. Guys, are you able to understand?
Sir,
Please tell me.
sir, what will happen if two strings are attached on either ends of the weighing stone?
Either ends of whom?
The weighing stone, sir.
You mean to say there is another string connected here?
No, sir, no, sir. From the thermocol itself, but two strings like on either ends of the weighing stone.
Okay, I understand. This is what you're asking. But before that, okay, I'll answer your question. But before that, I want a confirmation from everyone. I think Raghav asked me this question. Are you clear that why now you are able to understand what I meant? The tension
Yes,
will be
sir.
this. Yeah, right?
I thought, no, sir. Actually, I hear, sir, can you mark the point, sir? The top of the string as, can you mark it with some name?
1 and 2.
Yeah.
Okay.
Yeah, 1 and 2. So actually, I thought like 1 will be obviously greater than 2. The tension force will be greater because there will be more particles. But then only I saw the point that it is considered to be massless.
It is considered to be massless. This is because had there been weight, no, what you told is right.
Yes, sir.
Had there been weight, the tension at this point would have been more.
Yes, sir.
Right, that's right. Okay, now Subrajit asked me a question like what will happen if two strings are connected, right? If this is 40 Newton, your question is this, right?
Yes, sir.
Now what will happen is, here there will be a tension and here also there will be a tension, but depends on what kind of materials these are. Let's say one is made of copper and the other is made of aluminum or something like that for the time being, okay? Then the tension here will be T1 and here it will be T2. But if these two strings are still considered to be massless and inextensible, then the tension in that particular string at the other end will be T1. In the second string, it is going to be T2.
Sir, then wouldn't the object be slightly tilted?
No, that depends on values. That depends on values. I'm not getting into those parameters as well. My whole objective is to make this point get registered in your mind. Okay, I'm not talking about what exactly is going to happen to this block. It will be tilted, yes. But that again, it might be balanced depending on what is the value of T1 and T2. Unless we have a number in our hand, we can't speak. Okay, because
Okay,
there is
sir.
a reason. There is a reason for it. You will understand only in rotation mechanics. Because what will happen is this 40 Newton is there. No, there is a force acting here. There is something called as torque that will act. So you told tilted. No, tilted has something to do with rotation. So there is a rotational force called as torque. You need to understand all those concepts to have a visualization of what I'm speaking. Okay, so as of now, you can accept the fact that if the string is inextensible and massless, the tension at both ends of the string is going to be the same. That is the important point. As of now, you have to register in your mind. Okay, slowly you'll understand when I come to 7th chapter. Shall I proceed? Am I clear, guys?
Yes, sir.
So the second force is tension force is what we saw. Now what we will do, we will try to solve.
Sir,
Yeah. Please tell.
sir, I have another doubt, sir. Sir, like on the object, can there be from the same point two strings are attached, but on like either ends of the thermocol?
Yeah, yeah. Right? Is this your question? Is this what you asked?
Yes, sir. This is what I asked.
Yeah, it is possible. It is possible. You can do that. You see, different kinds of arrangements are taken only for. See, it depends, right? Why you do all these things only based on the requirement. If you take a simple example of hanging clothes in your house, you would have seen the string tied from one end to another end. Right? If you look at a basic logic of why we do it, it depends on the comfort of the person who's going to hang the clothes. If they are short enough, they are going to put it at a lower level. If they are tall enough, they will put it at a higher level. All those things are taken. In a similar way, depending on what is the requirement, you can do anything you want. Right? You're able to understand. It completely depends on what is the objective. But to answer your question, yes, this kind of a situation is possible. And I'll teach you a problem also based on this kind of a scenario.
Sir, that looks like a parachute.
This one, huh? Yeah, you can take that
Yes,
also
sir.
as an example. Yeah, you can take that as, because there also you have strings, right? So
Yes.
let's say your weight is suspended here. Yes, that is also a scenario, right? So it's a free body. So shall I explain what is a free body diagram? I'll just give you an outline since we have less time. The detailed explanation I'll do it tomorrow, and we'll solve some good problems based on this. It's an interesting topic. Okay. So what you understand, guys, the name suggests, right? Free body diagram. It is basically a diagram, obviously, with all the forces. So if you are able to draw a diagram with all the forces acting on individual objects of the system, write down the definition, guys. Diagram with all the forces acting on individual objects of the given system. Okay. Along with proper directions of it, or proper directions of force, is what we call it as a free body diagram. What exactly it is and how exactly they are supposed to draw, I'll explain it tomorrow. Okay, just write down the definition as
Sir, does tension depend upon the angle of string?
yes, it does. Because wherever you have a vector and an angle involved, right, other than 0 degrees or 90 degrees, we need to solve the problem using resolution. Are you able to understand? Means, for example, if I take the same problem, let's say this angle is theta, then this T1 can be resolved as T1 cos theta, and in this direction, if you keep T1 sin theta. You're able to understand? The same force is
Yes, sir.
actually getting divided into multiple values. Yes. So to answer your question, yes, it does. Okay.
Okay, sir.
That's it, guys. So I hope you guys could understand what is a normal and a tension force, right? If everybody has study material in your hand, I suggest you guys to read it once and come for tomorrow's class. If there are any other doubts you have in your mind, we can start with those doubts. Then we'll continue with the free body diagram. Okay. So that's it from my side, guys. Okay. If there are no doubts, we can wind up, and I'll see you all tomorrow.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.